Hello, hello, hello. Welcome to another stream, everyone. How are we doing? So, last stream we kind of got the block compressed textures all working, which is pretty great. The quality is a bit meh, but that's probably just the nature of BC1 compression. But, is that running every single frame? It is. Hang on a minute. That's very laggy. Pass 0. Right. And then it was up. It was load materials, the other one, where it goes. Yeah. Right. Yeah, so, we've got this BC1 compression working now. This is pretty nice. I wonder yeah, it's on. So, it does look very blocky. I think you can't really tell because there's emissive on this, so it's kind of masking some of the terrible block compression, but yeah, so we've got optional block compression now, basically, which is pretty nice. And we have 4 different test materials, which are made from a procedural material shader, which generates these sort of sphere maps textures. So here's one of them, actually, is another one. And that's what the albedo map looks like. It's all generated in shader code, just with noise functions and stuff. So, what we're going to be working on today, and hey there, Kraz, welcome. I'll answer your question in just one moment. Welcome, sir. Good to see you. So, what we're working on today is the asset files. So, we've got the ability to make these assets or these materials basically all with shader code. This is all with a single same shader, just changing some properties and stuff passed into the shader. So, essentially, we're going to have a way in the editor. So you have this thing called a procedural material. This is just a shader. I've got the text file here. Not procedural. It's called a proto material, and that is basically it's just compute shaders which run in a SPIVI, which are in a SPIVI compiled into a SPIVI file, and they also have a type that you sort of pass into it. So in our case, we have a material shader already. It's currently just in the graphics shaders file like every other shader. But you'll be able to have multiple passes and just do whatever the hell you want. In this one, it's like this noise-based virtual machine. It's pretty bananas, but I wanted to make a very generalized shader for my first shader. But the rest of them are going to be very... they'll probably be more specialized towards a certain group, a more defined group of textures to make. So this will allow you to basically put a bunch of noise functions down and combine them, and that will make a texture and shade that noise in with an albedo and emissive, or yeah, shade the material's albedo, emissive strength, metalness, roughness, and height, and the normal map, all from that noise value or different noise values. So be very flexible, and this is our first shader. So today we're going to be making the whole system, which allows you to, the asset files, which allows you to contain these proto materials, which is just a shader and its data structure. Then you have the material plan, there we go. Then we have the material file, which is basically an instance of the proto material with a certain set of properties. So you can imagine like the proto material is the shader which can compute all of these different materials, and the material is obviously the instance of that and the data you pass in to get this, right? So these are just all text files, and then we can run those text files through a material build system, which will load the shader, load the config, and then generate the material, save out to disk, make a thumbnail, and all that good stuff. So those are the editor proto materials and editor material. Then finally there'll be a baking process. Oh yeah, I just described the baking process. And that will output this sort of .mat file, which is the baked material asset, where it's literally just arrays of pixels for each of the PBR materials. So we're going to be building these asset files today. We might get most of the way through, we'll see. And then we will, after this, be getting started on the actual material building system. What's my plan for an art? Do you mean like an artist, or do you mean for just doing art, or for like? Yeah, I guess do you mean like how am I going to achieve the art? Basically, is that your question? So yeah, for these encoders. For these files, we've got this thing called an encoder system, which allows us to declare these data types through. Yeah, I want to put them in graphics, I think. So I guess we'll make a new file. I'm not a fan of new files, but that's the way my encoder system works. So we'll call it a. Should it go in the editor though? Yeah, these ones should go in the editor maybe. Editor material. Oh, I've already got one. Oh yeah, that's got to change now. Right, so we'll make a new file. So code, modules, editor, proto material. ANC now. I could do it via its extension, basically. Do something like that. Add proto material. ANC, that might be better. Right, so we need to declare right, so I think you need to put a version up top. Think. And then a magic. I forget these things. Target. Yeah, no version. That's all it's automatically done, isn't it? So that'll be target. It's a file. This doesn't go on the GPU. It's just file. So we've got file, GPU, memory, and some other one, I think. And networking. So that'll be. Akraz, my friend, you've not answered my question. What do you mean by artist? Oh, sorry. What do you mean by an art? Hey, how you doing, sir? Good to see you. Yeah, what do you mean by plan for an art? Do you mean plan for an artist? Or do you mean like for doing the art? How am I going to do the art? What's the question exactly? Yeah, do you mean like actually making them? Or do you mean like the tech behind it, if you will? Right, so a bit of a magic number. Oh yeah, so we want it in text format only. Now the magic number, we can do ASCII to hex. So I think I want it to be E. Kind of like process material, doesn't it? Basically. Yeah, making them. Yeah, so I don't really have an exact plan for that, but the idea is I build all the tooling, right? So there'll be a full editor where you can build materials and models, levels. Well, maybe not levels, so I might do procedural generation for levels, but some degree of level editing for at least maybe some testing purposes. Then, so the idea is the experience to actually create these assets will be will be in the inside the game itself or the engine, whatever you want to call it. And that will allow the person who's working on it to hopefully get a really good experience and quick iteration time. I don't think I'll be doing it. I can do it. I know I can do it. It's just there's obviously there's a lot of programming to do. It would be ideal if I could somehow figure out if I could get someone to do the art side of things and own it, right? And it's a very sort of it's going to need someone who's willing to do something completely weird and different than traditional sort of art pipelines in games, basically. And it's not 2D, it's 3D. So, yeah. I don't want to hire an artist because that costs money. But I need to find some way in which, like, okay, so, what's the way of saying it? I can't hire an artist because it costs money. So either there's two paths, right? I build this sort of like game and engine and then get it to this sort of, prototype it out to the point where there's a way for me to kind of have some form of funding or whatever, then that would be a possibility. Or maybe there's a point where I get to that point and some artist person goes, I really like the idea of this. I would love to jump on board and work with you in my spare time on this. Those are the sort of options which are possible from my current thinking, basically. Yeah, I know it does cost a lot of time and skill. I'm not saying I want to, take anyone's labor for free or anything. But it's just I'm saying that, I earn a wage, right? And and that wage goes towards paying for my family and household, right? There's no room in that. Like, the wage I earn is what you probably take and then give directly to an artist. You know what I mean? So there's no, there's no money to do that. So the only way is external funding, or if someone wants to work on the side, like I do, and then there'll be some form of agreement where it's like, hey, we'll, do this and that when the game is done or something. You know what I mean? That's all the level of. Yeah, those are the possibilities, basically. But yeah, until I get to it. Let me just see what order it's done. It won't invert it, will it? Yeah, of course. So we want the other way around. So it's PM E. There we go. We don't want it. So I guess what do we put? Do we want to fill it? Do we put an A in there at the end? Right, so inverted because like big Indian or some, no, sorry, little Indian or something like that. Anyway, whatever. So it's editor procedural material whatever the A stands for. Could be asset, could be material. We never know. So we want to declare a root. Did you do it before? I forget these things. Luckily I've got an example thing, but I've also got a docs. Okay, of course it's like that. So structure, and what is this one? Editor, procedural, not procedural, proto material. We'll call it proto mat. Proto materials go all in there. Rightio. Have you been at Kraz, have you been having that sort of experience with your project, figuring out how you're going to do art, or do you just sort of hand do all your art yourself? Hey JD Husk, how's it going? Welcome, sir. Right, so this proto material plane. You want to path to a SPIV file. So char SPIV, we could call it shader binary path. So I guess I'll do some const expression thing here. So that'll be, I've got to be careful with these namings. You know what, we won't do that. We'll just say how big do we want to make it? We do 256 is probably fine. It's stored in a text file anyway, so it won't store all 256 of them. Alright, what's the next one? So the next one is the name of the type. So this is the type that is going to be uploaded to the shader, and is the type which is going to be displayed, what the type is going to be edited in the editor. And how we've just got to do something really silly where we do a string compare of all the registered types that have been registered with this thing. Maybe it's in the editor actually. Maybe this goes in the graphics, I don't know. Yeah, it's hard to know. Yeah. Along with its encoder runtime type information, basically. And then this means that we can no, we don't need that anymore. That means we can do a lookup. So this would be that shader input type name, something like that. We'll do 64 is probably enough. Then you will need a list of textures that you want to create in different formats and dimensions. And then the number of shader passes that you want to run and the names of those shaders, and it's in an ordered list. So let's make a thing called a editor proto material texture. It's so damn long. Let's call it proto mat. Right. Maybe we should have shortened editor to ed, you know, as well. Yeah, it's probably a good idea. We'll work on that. So in here, we need the dimensions. Yeah, I guess the name. What is the name of the texture? So I guess we'll do 32 is probably enough. Hey Captain Chica, welcome. How's it going? I tried to learn this week Blender and Godot. or Godot, as people want to call it for some reason. For some reason, it's Godot. I don't know why. I think it's learned a few things, but they're not enough to do with just simple walking character, right? Yeah. Yeah, Blender's quite the learning curve. But yeah, it's very powerful once you know it. There's lots of things you can do in Blender. When I had to optimize my culling, what was it? Was it my culling? My tile binning for my spheres. I went into Blender and I made this. Was it an icosphere or something like that? And I used that as the way to. Yeah, it was really useful to like. Yeah, so rather than transforming a box from local space into screen space and getting the perfect screen ABB around that. Instead, I got this sort of icosphere, took all the vertices back, and I got a more tighter fitting box, and it increased the performance by about 10% of my ray tracer, my tile bend ray tracer. So I was like, quite good. But yeah, luckily I could just about use Blender to do that. Yeah. I didn't bring it down now. Yeah, sorry, I was going to sleep. I'll come down now. What is the ESC file format? It's a custom file format for describing a bunch of data formats basically, and it will produce serialization code for text and binary files, and it also helps you write packing code for GPU stuff. And yeah, so here's a test one, for example. It does like this is bit packed fields and stuff, or ranged fields, and yeah, with a custom accessor, so it could be like a vector3. If it's a file that gets saved to disk, you can do a variable length array. You can't do that for GPU. Yeah, it's got a bunch of cool stuff. So I made a little docs encoder. Yeah, so I've got it all written down on how it works. So it's just made for this project really because I thought I needed a way to declare custom data types and have support for versioning as well. So it's all, yeah, supports versioning too. So if I change this, I can either provide an upgrade or do non-breaking changes. And if you're in text mode, if your file only saves that to a text file, that you have lots of freedom to change it or add new fields basically, but not remove them. But if you save it as a binary one, you've got to be really careful on what you do. So yeah, it's pretty great. And it's got an option as well for doing text and binary. So that means you save it as a text file while you're making changes to the version. But then like when you want to do a release, you switch over to the binary one, and that's what gets released. So it's quite, yeah, the versioning system is quite flexible in that way as well. It's quite fun. But yeah, we're kind of using it now for declaring our material asset types. I need to be right back because I need to take my treadmill down for my wife so she can use it, but I'll be right back. BRB. Alright, welcome back everyone. So I just found that C# uses .NET tooling mostly, but actually toolchain needs to depend on is MS Visual. What does that mean, MS Visual? Because MS Visual is like part of the, there's MS Visual C++, Visual Basic, Visual, Visual just means like Microsoft just come in and make their own version. They don't usually. So right now the project is mainly focused on bringing up an engine, but not actually gameplay, right? Not quite yet. Yeah, we're just sort of getting the technology in to sort of work on said game. I kind of have a vague idea of what I want the game to be, but it's completely flexible right now. So we need probably an enum, editor, proto, material, texture type maybe. So we'll probably have like a... How do my enums work again? Do you have to do the whole thing? I don't think you have to. Yeah, you do. Good. Right. Texture type. We don't have 1D textures, so 2D, 3D. What do we have in... Oh, it's called resource type, isn't it? Right, 2D array, 3D, and cube. We'll just do 2D array and 3D for now. Oh yeah, we can't trust Microsoft Logic because you go from Xbox to Xbox 360 to Xbox One to Xbox Series or something like that. Yeah, very true. I don't know what MS Visual is. That's very strange. First time I'm hearing about it. Right. So because it's a text file, we also get default values as something to keep an eye out on, but we don't need them here. Right. And the other one, according to my documentation, was we needed the name, format, and dims. So the dims will be a U, like this one, vector 3. So yeah, it's one of them. Cool. So that's our material texture, so we can have an array of textures. Now, because this is a text file, we can use VLAs if we wanted to. So we'll say textures count. So as part of a procedural material, which is just basically a set of shaders, you can say, hey, I want these textures to be around, so like my shaders can use them, and then they can just do whatever they want when they do their passes, their shader passes. So here are the textures count, and voila. So the next structure we need is a shader. So the shader will have an entry point. What else? So entry point, is that all you need? I think so. Yeah, I think we'll leave it at that for now. But, it's going to have the input. Oh, crap. Oh, yeah. So, yeah, the input will probably, there'll be a buffer which contains the shader input type in there. There will be a shader. Oh, yeah, then there'll also be another buffer or something with all the textures that you can get access to, basically. Yeah. Cool. Yeah, so with these textures, then, so I guess if you sort of like add and remove a texture, I'm just thinking about if you edit this file, the CSON file, which is going to be saving out to. CSON is just a C version of JSON that I've made up. So when you change that CSON file, and let's say if you like add and remove a texture, so what it might be a good idea if you kind of have an ID for the texture, such that, or a name for. Oh, you've already got a name. Yeah, see, that's the thing, isn't it? It's like so I think there'll be this. There could either be this very. There could be like an array of resources, and you index into the array of resources, and you sort of cast it into what you want. Or you could make the user declare a structure, and then we can make the user declare a structure, and that can have all of the textures inside it. But then the only problem is you don't get the dimensions anymore. Because if the user was to declare their own. Yeah. Yeah, and if they declared their own structure, I don't really have the shader texture types in the sort of ENC files right now. There's something that could go in though. But yeah, it's interesting. Yeah, they'll need a format as well, obviously. So yeah, we need a way to declare a format. It's a bit of a bugger. Yeah, there's quite a lot of formats. You know, we have all of these. But I wonder for like material generation. So I don't have a way to get this enum in my encoder stuff as well. Yeah, I completely forgot about the formats. Oh, we could do a string. Yeah, that's the way around it, isn't it? If you don't have a hard-coded type, you just do strings. But not really a fan of that. Because I have a table with all the strings in it. So we could technically just go over and remap it. So you could call it a format string or something like that. So you could be like, it's terrible, but it's possible. Something like that. Not a fan, but it works. You know, it's only for the editor. It's only when you load it up. You just got to translate it and it's fine. But yeah. Right. So you got this type of material, the texture type, and the dims. Yeah. Yeah, so the other thing is they have to manually convert a index into a texture, basically. and with the right type in their shader. Whereas we could have declared a structure type. But then you will have this array and that structure type. So let's just stick with one of them. I think that'll be okay. Cool, so this is looking good. So what the sort of the entry point name. Something like that. Have your array of shaders as well. So shaders count. So I think we'll stick these at the top because there's just a bunch of arrays everywhere basically. And so it'd be material shaders count. Right, so I think that's quite alright for our procedural material. That will be good enough. Now, so we should probably try to now model our existing shader that we've got that generates these four materials, right? We've got one shader which does all this. It's this crazy noise function thing. So around bad news, decided to go with OpenGL, then make Vulkan my main renderer layer. Now that makes sense. If you've not done, if you've not done much 3D rendering or anything like that, OpenGL definitely makes a lot of sense. But if you I kind of forget exactly this stuff you talked about in the past. Do you have you got much experience with 3D rendering at all, or have you done any projects in the past? Right, so let's get this in the. So I've got this like encoder builder, I think it's called. Dave's encoder. Encoder code gen. Yeah. So right now we just have a list of files. It is not the best in here. I might shorten editor to ed in a sec. But let's do that. So we rerun the code gen script. Ta-da! We should have. You have none, right? So what I recommend is that you build a software renderer. It'll be a lot more fun, trust me. So I gave this advice to Not So Red. I'll send you this link. And he went like to the moon and back with this. It's really cool. Like he's implemented like a full PBR renderer in software, so it's all done on the CPU. So the most annoying thing about the GPU is that you have to interact with a GPU. And the people who have made the GPU drivers and software and everything is very abstract, and there's this whole mental model that you have to grasp. And it's just easier if you basically try and re-implement a very simple version of it on the CPU side and understand exactly or how such thing can be implemented, and that will really set your it'll really help you understand OpenGL and Vulkan a lot more. So I recommend what you do is you learn about how to rasterize a triangle, and with that you can then basically make your own API, which is like, you know, you have a pixel shader and a vertex shader, right? And you know, frame buffers and stuff like this, right? Well, probably not frame buffers, just have textures, don't have frame buffers. And you know, there's a thing called a pipeline with a bunch of different state that you can change, right? Stuff like this. How does that affect the rasterizer under the hood, well, you've implemented it, so you can figure that one out. And try and learn these APIs by trying to implement your own version, but in a very simple way. So yeah, I highly recommend you look at this repo here, and it's got resources at the bottom as well. And by the way, this is all in 1,000 lines of code. 1,000 lines of code you can do. You have a whole renderer basically. So it's not that hard in comparison to what you might think it might be. And then after this, I recommend, rather than going to OpenGL, is try SDL3. Because SDL3 is an abstraction on top of Vulkan. And, well, okay, SDL3 GPU. So SDL3 is an abstraction layer across CPU side, window management, and all sorts of things. Control, like input devices. It's pretty cool. I've used it in the past, but SDL3 came out recently, but it's also got a GPU layer. Now this GPU layer abstracts over Vulkan, Metal, and I think DirectX, I forget. Or it's Web GPU, I don't know. It abstracts over stuff, the new stuff. So it means that you can run it on all the hardware you probably want to run it on for now. And the best thing about it is you can learn how one might structure an API around Vulkan, right? You obviously, when you get more in the weeds in your own project, you'll do it differently, but it just gives you that sort of first base, and it's really good actually. A good first base to be on. It's not a toy API or anything. So there's SDL until GPU. So when you're using SDL3, you can get going with this, and it's quite right. You can, like, if someone was making an indie game and they want to roll their own engine, like this is good enough to use. Build a rasterizer or software renderer. They're both the same thing. A rasterizer in software. So a rasterizer is like, it's to do with like turning a triangle into pixels, and then yeah, build the software renderer as well once you've done that. But remember, keep it as simple as possible. If you used to be inspired by the GitHub repo that I've sent you, to keep it that simple. I solved the problem. Hey there, Lech. Welcome. I solved the problem having multiple files for a meta program, but only having one file. Right. Yeah, I do hate having tons of files. I don't like it. But the way I've designed my encoder system right now is that one file format has a file. And I don't know how much of a good idea it is, but it means, yeah, maybe I can have ways to combine them if it gets too out of hand. There's a lot of stuff that gets generated, and I'm not a big fan of it. I could probably have multiple roots, file roots, and that might be easy enough to do. But yeah, well, no, because they're versioned. That's the thing, is they're versioned, and you change the version of all your files. Otherwise, yeah, they have to be separate. Most annoying thing with GPU is not the GPU, but the operating system itself, because the operating system all of a sudden can say, well, you don't have GPU. Can it? Well, I have a good grasp of C++. You recommend learning C? I know there are like... Yeah, well, C, C is it depends, right? Like, I would say, because I think there's, like, for me, C is enough. Like, it doesn't annoy me that it's not got all those C++ features. But if you're a person who really loves C++, then obviously keep using it. But I would I would suggest try not using C++ and just see how much of those C++ features get in the way of solving a problem. You know, you don't actually need, like, I would argue, any of the C++ features to for a game project, or, you know, I rarely use, like, the only time I need to use templates is when I made my array and my hash table and my object pool, and they're just collections. And they're the only times I've really needed to have templates. So, yeah. Hey, JMod, Aurelie, welcome. Yeah, I'm doing alright, thank you. I had a couple of stressful days, to be honest, but doing alright. It's my birthday on Thursday, so we won't have a Thursday stream, but yeah, things are going alright. Things are going good, thank you. Oh, I need to recompile the code generator. I don't have a build system right now, as you can tell. There's something I've partly worked off stream, but yeah, anyway. Right, so that's the generated one with all the types and stuff, which is pretty sweet. So yeah, so we could then make our, how would we do it then? So it would be an asset, would it be in the assets? There's so many damn files, I hate this. So I think in the assets directory, we can put, I have an assets folder, great. So there's materials. So we probably have our proto materials in one, and that will declare the CSON file and another encoder file, which will have, oh, you gotta be careful of those damn data types. Something like this. So that would just be a bunch of like CSON files, maybe. Right, so that's the file definition. So that'll be in assets, proto materials. Right, so this one was like a noise-based virtual machine thing. It's pretty crazy. So I could call it general, right? It's just a general. If I just call it general, yeah. There's just we just generated a bunch of general materials basically. So we did. So I think it'd be editor, proto, map. That's just like this CSON file. So I think you put the magic in there, isn't it? Get these things. Version, right? So version 0. And then, right, here we go. So editor, proto. Can I move this over a bit? I think it's alright. Yeah, it's fine, good. Proto map. So it's just basically C like JSON, that's all it is. Right, so we're not really gonna have any textures. Yeah, we just have a single pass, and then we need a way to generate the null. Yeah, we probably also want to say, does it Yeah, okay. I think it'll always generate the normal map. So we have textures count 0, shaders count 1 pass, then shader binary path. Now, so I'm thinking for now I'll just leave them inside the, so they'll be in code, modules, graphics, graphic shaders.c. Oh crap, this is the spivvy binary though, so that's in build. Shaders.spivvy. Alright. Then it's this binary path. Then shader input type name. So I haven't done this yet. This will be another ENC file. So this will be known as the, so this one will be called probably just protomat general. We'll call it that. Okay. So no textures but shaders. So just be like that, but you need to do this. Protomat shader. So yeah, it's kind of like a typed JSON already as well. Should you add all that pipeline state stuff? Yeah, because you learn about like how basically the API works currently. Like in Vulkan, you have this sort of pipeline state object, and those are things that you configure to change how the rasterizer works under the hood, and that building that in software will teach you a lot about what happens when you change those variables in Vulkan. So yeah, build something like that and take a look into how the Vulkan pipeline state object looks and see if there's any ones that are missing. Namespaces are nice when it comes to grouping stuff, but man, the C++ thing sucks. Yeah, see, namespaces are just pointless though, because they're, again, this is what happens, right? C++. X feature is nice, right? When you say X feature is nice, like, it's just, yeah. Like, just because something is nice doesn't mean it's good. I think that's the biggest problem. Namespaces. If you just have a structure like this, right, I can search the whole code base and find exactly where your thing is with a string search. When you have namespaces, I can't do that. When you have methods, I can't do that. So it makes it really handy when I'm using a tool which doesn't have it. You know, like on a web browser or something like that. When, you know, there's tons of reasons. There's another one. What was it? There's yeah. It just means as well when you're reading the code, when I read this, I know it's from the editor, right? When someone tries and brings in their namespace, and they get rid of some of these things and just include it in. Now I've got to go, okay, go up to the top of the file, have a look at the thing they've imported. Oh, it's from there, you know, and then try and find it in that module and everything like that. Yeah, it's just a whole can of worms. Yeah, there's another one when it comes to like importing the namespace as well. There's some, but I can't exactly remember it. But yeah, they're basically pointless. It's just a custom one I come up with. It's just basically just take JSON, the idea of that, but just do the C initializer syntax. And that's it. It's text. Right, shaders. So that's actually an array. So I think, did I use special brackets for that? I don't think I did. Yeah, no. Yes, it's the standard C-lab brackets and stuff. Right, so entry point name. So this would be proto-mat general. So I could just say pass 0, but there is only one. There's only going to be one pass. But let's say pass 0, because I think I want to make that a thing where, you know, a thing that we do. Yeah, so that's how one can simply be written out. It's not very complicated, but you need the additional ENC file to describe the data that's been passed up to it. Now, the problem is if I put it in here, it's then an asset that's going to be code generated and stuff like that. It's a bit annoying. You know, I was in the plan in the previous stream. I did describe it as the data definition rather than being a type that you name that you pass in or whatever. You describe the data definition within here, but then the problem with that approach is that when you come to read the data out of the shader, it's just so disconnected and error prone because it could be some, you know, you'd have to write some functions to grab a float or something like that, and supporting structures and arrays would just be weird. So if we compile it into the editor for now, I was thinking I might want ways for people in the future to have like mods or something where they can have their own procedural materials and that. But I guess if they're already compiling shader code, they'll probably be compiling another bit of code along with it as well. So maybe the idea would be yeah. Yeah, so maybe I put it in with the code. Well, it has to go in with code. It is code. In the editor, I guess. I'm getting quite a lot of down files here. I don't like it. But yeah, I can have another ENC file, which is just proto materials. And it's just got all of the types in there. And I think I'll be happy with that. Yeah, but if you change one and it changes the version of it. So it's used on GPU and it's saved out to a file. Yeah, I think this maybe deserves maybe a folder because it gets rid of all the clutter. It's probably a wise idea. But yeah, so you got all these like editor file formats and stuff, and all right, so proto materials, something like that, and then in here we'll probably have the ENC file, which is slightly different. So I guess let's just, you know, work on that next, and we'll worry about where we put all the things in a second. So that'll be like a, let's close these up and open code modules editor pro materials general.enc. So for this one, it's going to be both file and GPU, which means you can't have text support, so we need binary. And so this would just be known as the proto material general, something like that. So proto material general, so that would be EGMP. Right. So I've already declared all these structures before. They are in the shaders file. So I need to have a way to fish them out. So it's basically all of this. We've just got to massage it into the encoder file. It's all very similar syntax, where it's just C syntax. VM. Probably, isn't it? Yeah. Just my 2 cents. Building software rasterizer from reverse engineering APIs docs just sounds hard. Understanding the docs is easier if you can also test them out and running program. Create rasterizer after learning parts of a simple graphics API. Maybe. The docs are a bit crazy to understand, but I'm sure that you can look at tutorials and piece together what's going on. The problem is learning OpenGL it's just old and terrible. Like, it doesn't map. Like, it's probably better to learn STL3 GPU API than it is OpenGL. Yeah, I think it's just better if you learn doing it software first, because that's the way that people learn in the past. Yeah. I do understand why people like OpenGL, because Vulkan is like just such a complicated beast. Alright, so would we stick this? So the thing is about this FBM thing, and then I've got the simplex noise in that. So I guess these will just be part of that shader. They shouldn't really be generalized. And I guess, yeah, because yeah, I didn't need them in a general place, maybe. Yeah. So what we'll do is we'll right, here's the general ENC file. Excellent. Right, so it's GPU, so we've got to be careful on what we use on GPU. We can't use a few features like they have to be 4-byte types. You can't use a variable length array, stuff like that. So I probably want to call it protomat general. There's a lot of prefixing though. Got to be careful. Noise type 3D. Something like this will do. So FBM fractal Brownian motion. So those are all work. Now we don't have hash defines. I end up putting in const expressions into this just because it made the most sense. Linear. Yeah, so I got sort of like noise prefix here, but it should probably go because that's how we the lerp color space. Right, noise color edge, yeah. So this color edge thing is basically defining a gradient. So you take a noise value between 0 and 1, and how do you turn that into like a color, basically? So you can have different edges and it lerps in between those. And this lerp thing just, allows you to lerp in RGB space or OK Lab, so you can choose that. So grad is the gradient. It's just, an array of the edges. Noise pow. Pow pow. Cool. That's pretty nice. Right, let's move these constants to the top. So because it's a binary file, gotta be careful with this actually. Yeah, because it's a binary file, if we decide to add more things to it, it's going to be a problem. But if we save that out as text as well, it could mean that we're allowed to add stuff to it. Oh yeah, no, yes, binary. Oh. No. You can support text mode on GPU. Remember, I had this problem. Yes, you say text and binary, but yes, it can save that. It can be saved out as text in a file, but yeah, so it's never saved out as a binary. It's only saved out as text, but it's used in binary mode on the GPU. Yes. So that way we'll be able to change this format without changing the version. We can always add new stuff, but not delete stuff. And if we want to change the version, that will allow us to delete stuff. Yep. Amazing. Amazing. So this is an operation to take a noise value and turn it into albedo, emissive strength, melness, roughness, and height. There's some coordinate space thing. And then there's the opcodes. It's just a stack-based VM in a shader. Super cringy, but it's flexible. And it's fast enough for build time assets, so yeah. And then people don't have to drop into an editor and start writing code, basically. Right. Is that even supported? I don't know if it is. Maybe. Right, so here's the input structure. PMAT, general, input. So it's just got an array of operations. And I think at most we support is 32 operations. Yeah, 32 different operations. That should be enough, but maybe it won't be. We'll see. Yeah, so if we go back to... See, I wonder if this will work. So we go into encoded code gen. Got to add this in here now. So it's editor, proto, materials, then general. That was it. So we rerun, we'll rebuild the tools and then rebuild the... Right, unrecognized name float. Alright, see what else? Color 32, okay. Yeah, so that's on line... okay, I see. Whoops. Yeah, so I can't do anonymous structures. That's okay. So we don't have support for unions on GPU, so I've just got a fat structure. And again, this is fine because it's only... yeah. This is fine because it is only declared on... or first making assets, basically. It's not bundled with a game or anything like that. So it could be a bit wasteful. Right, see how this looks? FBM. Right, so it's PMAT general. '86, sorry, no type def, and voila, no. Right, we need a root. So this is the root type for the file. Right, that worked. So no errors there. So this will allow us to declare CSON files now with this layout. Now, we're not going to write any by hand. This is what the editor is going to output. So in general, right, not for this shader called, not for this procedural material called general, but when we have new procedural materials, the editor will be able to look at the type information generated from this ENC file, which we've just done, and display a bunch of like properties on the side that you can just drag and see your changes visually happen. Now this one's more complicated to the point where it's got like arrays and structures inside it. So for when it's this level of complexity, it's got to have a custom editor. And I don't think a lot of them will have this. Usually they'll just have like a bunch of colors and floats and stuff that you can change. So yeah, that's that one. Right. So let's go back to that. There's that other CSON or ed proto map, but it's just a CSON file. So we end up calling this PMAT general. Yeah, PMAT general. Input, calling it maybe. I could just call it PMAT general. You know, what's the point of putting input on the end? Yeah. So, right. So let's revise what we've got. So this should be everything for procedural materials now to... Yeah. So I guess let's get all these file managers open just to sort of see what we've just made and figure out if there's a way to make it better. So we've got this sort of in the editor folder, which I want to rename to ed at some point. We've got this procedural materials where all this sort of code gen will go, related to procedural material input data. Then another problem is you have an assets folder where you've got all your procedural materials in here, but this is probably okay because when we like browse the file system for different assets, right? This procedural material is an asset itself, right? So when you want to say make a new material, you're browsing for a procedural material, clicking on that, and then you can go and tweak some properties in the editor to make a new material. So I think this makes sense to be here. This is the file, what it looks like, and that's okay, I guess. Right, so we've got those things. So I guess I'm happy with that for now. You know, and as I said, if someone wants to, if in the future we did mods or anything like this, or had ways to do these things outside the engine, there will probably be a way to load like a DLL or something, and custom shaders. So the user would just have to make their own versions of these in their folder, and that, yeah, that would make sense. So that is, we've not got rid of that possibility. Right, so the other thing to see if we can make better, so I've got this editor folder. This is probably well, there's going to be more ENC files basically for declaring file formats and things. So I'm just thinking, do we just make a folder called formats, or files, or assets, like editor assets, and then all of the asset related stuff just for the file definitions, and that just goes into there. We've got an editor for a level, a model, and a material. So yeah, I think having these just loose in here just kind of gets a bit annoying. I could make there's going to be, it's just a bit much. So let's take this and call it but if I use the name assets, it make it seem like it is like actual assets. I could call it asset definitions, but then it's long. Asset defs is just, a bit weird, but yeah, we made a thing called assets. Is that good enough? I could call it formats. Well, it's specifically file formats, isn't it? Asset formats. Yeah, maybe. So here's the other thing as well, is I've got the baked version as well to do. And that I wanted to put into like graphics or something. The graphics folder. Maybe we just need another directory where these just all go. Yeah, let's have a bit of a think about it. So we've got one for settings already. We got sort of the settings file and stuff like that. Right, maybe we just have another folder where where a lot of the code gen stuff goes, all the file formats and that. That could be maybe even the procedural material. So rather than having this folder in here, we just have one place. So if you make a new asset type or something like that, it's not even an asset type, but so I've already got the ENC file that, module. This is specifically for the actual declaring all of the common code around the encoder system, basically, serializing to text and binary and the runtime types and stuff. So I don't want to put it into there because that's kind of the underlying system. And asset is sort of the underlying system for loading assets, but not assets themselves or anything like that. So, there is sort of a applications modules, but it is code, right? So it's kind of like an asset file format, but then you've also got like settings and stuff, and maybe you have stuff for yeah. So the best thing is they could really be outside of the modules, because they don't really have any dependencies on other things. They're kind of isolated. When they're code generated, they're always isolated types. So it might be wise to stick them in their own thing. And we can call this like encoder formats. Maybe. Something like that. So in graphics, we've also got graphics shared, which is do all like the packing data. So, helps pack stuff for GPU basically. Stuff like that. So that wouldn't go into there because it's kind of nice being around here. And maybe the settings one wouldn't really go into there either. Because perhaps it is nice, to be part of this system. So maybe... Yeah, I wonder, maybe we could put it into its own folder. Because either it's going to litter in these other ones, and we might get quite a few. So maybe we'll call them asset types. Asset file formats. Asset definitions. So maybe we think, specifically for assets. Wonder would it belong to the editor though? Yeah, because these ones kind of belong to the editor in a way. Although the graphics code will want to use them to... Yeah. Yeah, maybe not asset formats though, because you've got this procedural materials that you might want to... Right, let's make called assets formats in here. And we'll move all these ones in for now. We can always change it. Alright, so those go in there. Thank you. Let's close this. Material generated. We're getting rid of this now, right? That's the old one. Yeah, we'll need to... We'll delete that when we remove the editors for that. We'll keep it around for now. It's the old one. Right, that's good. Okay, so we go back into Helix. We go to code generator. Find the list. We just got to move this one into asset formats. There we go. Beautiful. Cool. Alright, let's build the tools, recode gen just in case. Why is it trying to remove... What's going on there? What's that? So general... Right, something busted with my... Ah, right. So my database file, I had the word input in there, but I removed it. Yes, I couldn't rename the type. Yeah, okay. Well, there we go. I've just renamed it. Done. Just, you know. So the encoder system has a database file which keeps the history, and you can tweak it, but you shouldn't really do that. There we go. Cool. Yeah, that works really well. Yes, I'm happy with that. So, right, what we're going to do next, should we declare some for... What should we do next? So we've done this proto material now. I'm quite happy how it's turned out. So that's a way to declare some kind of sets of shaders which run, right? And what textures they need to generate into, and you know, that sort of stuff. We've also copied all of the input type for the procedure material we've already made into this definitions file now. So the next thing is we need to actually have an editor material, which is just a kind of a CSON file again, but with an edmat extension, which is an instance of that general ENC file, right? So this is the all the input data basically. So if we could write up a CSON file which takes some, maybe we'll just take these ones here that we've already made, right? The inputs that made these, and convert for that. Or maybe we'll just take this one for now. Or maybe we'll take all of them. Yeah, let's take these 4 over, and then we shall. Yes, different CSON files, and then that'll be this procedural mat thing done. We need to make sure that we either encode the magic number in there, or we find a way to read it before choosing the type to decode. Yeah, we need to do that. So the problem is this .ed material could be for any single procedural material, right? Not just this one that we've just made, right? This super this one that could be used to make a bunch of different materials basically. It's not very specific at all. But when you make this ed material, it could be used for any any proto material. So we probably want a way to identify that via maybe a magic number, like the magic number of the proto material, or perhaps some other way. So I've got to figure that one out. Right, I'm just going to take a quick break, and then we'll come back. We'll write out the 4 files, the 4 CSON files, and then we'll figure out this magic number problem. Well, it's not magic number problem. The problem where we want to identify what proto material the material actually references. We'll figure out how we do that. Right. BRB. Hello everybody, welcome back. So we're gonna create some materials by defining them in this custom CSON file now. So I've already got these declared, they're hard-coded into a shader. And it's the same shader that generates these 4 different materials. So we want to take those, put them into a CSON file, which is basically JSON, but kind of C looking. Well, it is C looking. That's the idea. So we are going to want to put them inside the assets materials folder. So we can call this one volcanic ground or something, and then it'd be good. So open assets materials volcanic ground. Now here's the thing, right? Here's the thing. These will typically be made. Oh no, these will always be made inside the editor, but we don't have the editor yet. So we're gonna write them out in this text format. But yeah, it will be tweakable from in the editor, live editing, and all this. It'll be great. That's what we'll be building. Probably April, somewhere like there. Okay, so we need the magic number, is that right? No, the version 0 of the... Yeah. So this is where we probably need to encode the magic number somewhere as well. Yeah, something like that. But anyways, so the proto material it comes from is inside code modules. You know what? Why am I even looking at it here? Let's go into the shaders. Right. Here we go. So material 2, yeah, this is it. So submaterial 0, this is the one. It's got 6 operations. It's kind of a crazy virtual machine thing in a shader. This is the way. So yeah, we're just gonna port this in here, plop it in. So I think it's called PMAT General. So proto material. I keep calling it procedural material. Yeah, proto material. And do something like that. Then ops count. That is definitely it. So we do 6. Then we have ops, and then it's an array. So it's an array of PMAT general op, right? And then these are just, we've got an opcode, which is quite nice. So when we have something like this, we could replace that with PMAT opcode. PMAT general opcode. Yup. Then this sort of noise chord space is going to be remapped to PMAT general chord space. That's it. Then that's all right. The new line, we're gonna have different new lines though. Sorry, yeah, different terminators on the lines. So commas rather than semicolons. Yeah, so now it's just keep doing that, I think. Let's go to a test CSON and see what it looks like. So it's, yeah, array. Yeah, that's it. Oh, I need to change that in my, yeah, well. Yeah, that would be nice when I get the C sort of syntax highlighting. That is in... What was it? Config, Helix. Yeah, languages C. Right, here we go. I can plot more on here. So CSON, edmat, proto, edmat. No, ed protomat. Yeah, editor proto material. Nice. So let's see looking syntax when we reload it. Ah, there we go. Boom. I like the CSON format. Did you go over how to parse it in one of your previous streams? Yeah, so I wrote this whole thing on stream. So if we go to VOD, the VOD channel, I wrote the whole system on here. Why am I trying to go to it after I just linked you to it? Yeah, so on the VOD channel, if you look for like encoder, it's somewhere. Yeah, I've gone past it already. Yeah, so it starts from, it took a bit. So 161 to 176. So that's the whole thing from scratch, including the documentation, the serializing text to binary, kind of figuring out the whole system as well. I obviously did some of the things off stream. But yeah, it does versioning as well. But specifically the CSON thing, I think that might be the text reader and the text writer. Maybe. Yeah, I think these are them. And I think that's it with my longer hair. And then I added versioning after that. But yeah. Oh yeah, the color picker streams, those were good. That color picker is really good. I love it. So cool. No worries. Yeah, it's basically, you know, types of JSON. Like, why don't we have this? And, you know, now. So that's always what I do, right? When I look at technology that people use and I go, but why don't we have this? And, you know, whatever that improvement is, and just really do that. Because it's a lot of fun. It also supports doing these as well, I think. Wait, did I add that yet? No, I don't think I added that yet. But yeah, I think it'd be a good idea to support that at some point. Yeah, it's quite alright. Wait, ops 3. But yeah, also Jmod, you also have the code, right? You're a subscriber to the stream, my friend. So you can get access to the code over you know, I'm sure you have it, right? It's inside the enc.h file, I think. Or internal. Yeah, enc.c is got the implementation, but the internal header's got the CSON writer, the CSON reader. So you can look at how that code works. You don't necessarily have to watch the whole streams because they're quite long. But yeah. Take a look at the actual code. Yeah. So, and then the encoder system generates code for each of the types basically that you define in the file, and it will serialize it and deserialize it with versioning and all that. So yeah, it's quite easy to make a serializer and deserializer. But yeah, I wouldn't. But yeah, text is great for, like, you know, for certain things, but I wouldn't use text for everything because there's a lot of pressure. It's far more expensive to decode it than it is just the, just to read in a file as binary. But yeah, it's good. It's good for when you want to have compatibility between, or sorry, if you want to change the formats kind of regularly by adding new stuff. Text is great for that, whereas it isn't for binary. So I've got ways to use text for when you're making a change and developing a new feature, you can use it in text mode, and then when you release the game, you can switch to release it in ones and zeros. So it's all fast. Well, I think that's it. So that'd be the first one. Now, yeah, I wonder whether I want to get the rest over. Yeah, let's get the rest over. So that's volcanic ground. Well, I'm already interested. We call it rocky hair because it's got the comb over. Rocky comb over. I don't know. Maybe we'll just do the one. I can't be bothered to write out more of these. This will be enough. We only need one of them to work. These are very, very easy to make. It's not, when we build the editor, we'll make them really quick. So it's not the end of the world. Right, so let's crack on with solving more problems. So we've got this first material, which is great. The problem is like when you click on this asset in the editor, you'll be like, oh, what procedural material does this belong to? So in a way which is compatible with every single editor material format, right? We need a way to get it to link to that procedural material. So I was thinking we could encode the magic number in here, and that means when you parse this, so they'll have to have unique magic numbers, but that's right. Yes, that was it's called general, wasn't it? Yeah, so I called it P for procedural material, then GE for general. But I've only got 2 characters there if I have that sort of standard. I could swap out the first bit for something. I think I keep on down procedural. Damn it. Maybe I should just change the procedural material on the proto. But yeah, proto material. Yes, I think if we put the magic number inside the there's two choices basically. Either we have 2 kind of extensions in a sense, right? You have 2 dots, right? Or you just put the magic number. Yeah, I think the magic number would be best. So that means you can't change the magic number. Makes sense to not change the magic number. Okay, so that would then be right. So I reckon we could probably end it with 0, 1 or something like that. The 0, 1 would mean editor proto materials basically, and then gen is the the next 3 bytes for whatever proto material type you want to. So you got at least 3 characters to, so you got a whole 24 bits to make your thing unique rather than 16 bits. Well, 16 bits might be enough, but yeah, whatever. I think this is better. So we'll delete the database file because otherwise it's going to complain, I think. Well, let's test it. Does it complain? Yeah, the magic number mismatches the database. So yeah, we don't have any assets like that at the moment, so we'll need to. So we have to change the encoder system. Where the hell are they? Yeah, delete the database. Cool. Yeah, so we're going to have to change the encoder system to make sure that we output the magic number and parse it in the CSON file. That's what we need to do. So, yeah, I guess let's try and get that to work. And then we can try and parse it maybe. Yeah. So it's going to the encoder system. In C.C. There's like a CSON. It's already reading the version, right? So it's already looking for this sort of like hash CSON reader version. So it's already reading that, right? Okay, so we also want to read the magic. So I wonder where this is. Yeah, so my code gen is outputting that as part of the decode step, right? So then, yeah, that's what goes out. Okay, so interesting. So also we want to change the. Yeah, we need a way to say, can you just parse me the version and the magic number of this CSON file? And that would also be a very useful utility too. So let's change the documentation first. Yes, that's going to be one of them. So I think hash version. Oh, so past Henry did do it this way, and then I removed it. Man, what a good guy that past Henry was. What a bugger. And then a more present Henry decided to remove it. Man, all these iterations of Henry ruining things. Okay, so documentation says it works that way, but it doesn't. Okay, let's fix it. So, reader, we're going to want to read the magic number. So read magic out. So hash magic text reader right, version string so the magic is going to be 32, that's for sure. Isn't there two types of... Oh yeah. I mean the data type hash, isn't it? Oh yeah, that's for the branching versions. Right. Did we put the data type hash in the binary header? We did. Yeah, I wonder, do we want to put some of this information in there? The hash of the data types. So the hash of the data types is there, so if you change stuff between branches and add new versions, it can detect the clash. I forget if there's ways to solve it, to be honest. You have to manually do it, I think. There's no way to automatically do it. Data types hash is encoded in the version directive, so we can check if the past version is modified at all. Also, this is used to possibly support branching in the future. Yeah. Which we don't need now, so we're not supporting it. Right, it's encoded in the version directive to check if the past versions have been modified at all. Right. Yeah, I don't think we need it. Which is fine. So that is... Go to the new line. Alright, so let's get an example. Cool, so we won't decode it specifically as hex, but we could probably say it should be... No, yeah, it should be in hex. Yeah, so... Good. Right, so we just want a UL. No, a U. Oh, whatever. Yeah, I'll do U64, screw it, okay, that'll be fine. Yeah. Yeah, that's good. So yeah, must start with magic. And then the version. Yeah, something like that. Cool, so we'll go to the header file, and then we'll throw that in there. Bit of magic. Got a version, bit of magic. So you would think you put the version first, but the version is the version of the file format, not the version of the encoder system itself. We don't need that for the text ones. Right, so now we need to change the code generator. So specifically for the reader, this is an example of what gets generated. We want to basically code gen another one where we do magic like that, right? Now, the thing is about the magic we've got to be careful with is right, so usually it switches on the version, but I think maybe we could put an if statement in. So there is the encoder to decode memory. There's the CSON as a string. There's the binary writer. Is it in the binary writer? There's a where? Yeah, there is the metadata somewhere. Yes, a binary writer start v0 settings. So I think that's got a v0 settings underscore file metadata, isn't it? Yeah, it's one of these. So I think we want to say like if there's a version mismatch. Oh, there's an error message. What's that about? Ah, interesting. Yeah. So I think we can pass in like what is the expected. We can do something like this, right? Dot magic number, I think. So that's file metadata. That's just called magic. Yes, I think that's what we want. So back into that magic thing here. So there's a magic out, and we kind of want to put in like an expected bit of magic. Whoops. Yeah, I'm interested. What is... Oh, crap. Right, so after you parse the magic, you can go if expected magic is not equal to magic out. Then return false and set the error. So it's not done in the code generator, it's done in here. So we can say magic expecting to be 0x begot 0x something like that, right? So we get rid of that hint. Yeah, so we'll pass in. Yeah, it's variable args. Good. So expected it to be expected magic, and then magic out. Nice. So we just got to plop this change into the header file. There we go. Nice. Right, so that's good. So I'm just double checking, like when we did this reader version thing. Yeah, when the settings fails, it copies some. Yeah, so what happens if you don't have the right version? There should be something maybe. Yeah, so say if you read a version. That doesn't exist. I think the binary one. How does the binary one work? Yes, it's got the verify. And the verify, we'll say the version has to be, yeah, it's newer, right? So we've already got that checked there. We haven't got it for the CSON. So I think then for CSON, it's probably going to be wise to put a default down in here. So we'll put error message, and then it's gonna read an error message, and then binary upgrade. What's that doing exactly? Right. Yeah, but if you didn't get a file version. Yeah. Right. So we'll basically put into the, we'll smprintf into there, I think, an error. So we go over all the versions, and that has a file version number. We could just do, I think we'll do the expected version thing. That'll be better. Yeah, let's do expected. So we've got that in, or we've got like a max latest version, something like that. Yeah, we'll do this way. This sort of error message is what we want. Yes, so expecting hash version to be no greater than, so we've got to say if latest version is less than Yeah, maybe we can label it better. Hash version this is newer than our latest supported version of that. Okay, I think that will work very well. So version out, latest version. Very nice. So CSON reader error. Boom. Return false. So just to double check. So it copies the error and then does the upgrade. I guess, yeah. Oh, no. It will copy the error message and return because you return false. Yes, perfect. Amazing. That's good. Right, I like that. So that's the reader side of things done. Now we're going to fix CSON writer. So where does it write the version out? So we'll go to the same ones. So we're looking for, so this is CSON encode. This is just some code generated code, right? Encode memory. So writer version, it just writes it out like that, yeah? So it takes in the file metadata for some reason. Seems a bit silly. It should just be a number, but yeah, I think I used to encode two things out because I used to encode the encoder version as well. We ain't doing that anymore. Yeah, we'll change it to U32 again. So doing magic as well. Right, so what's going on here? This looks really weird. So I'm sort of getting the size of it. Oh yeah, allocating the amount and then actually putting it in there. Yeah, I could make a general function for this, but there you go. Right. So instead of version, bit of magic. That's how we like it. Then in the code generator, when we use this, we just need to simply right. Why don't I see this? See, so let's look for CSON encode mem. It should show up. CSON encode mem. Right. Yeah, file version right there. I don't know why that didn't show up. Anyway, so we copy paste that. Then we write a bit of magic. So this would be .magic.version. I think it's file version. Yep. Cool. So let's go ahead and recompile the tool. I thought okay, I didn't change that. And version. Ooh, our latest version. There we go. Right, so rebuilt the tools and code gen, voila. So we should have the new, I don't know what to look for, generated. So any one of these will do it really. So reload. So a writer. Hey, we're not doing a pointer anymore. No pointer there. No putter. Right. Rebuild, regen, reload. The linter seems to like that one. Then decode. Right, so it's file version instead. Yeah, we're right. Nearly there. Go to the extra new line, call it file version, and voila. Cool. So that's going to help us now. So what problem did we just solve with this? Alright, there we go. So what we've solved is now when we read a CSON file, we can tell like what file format this is for. And this means that we probably need a general way to say, hey, I've got a bunch of bytes. Like I've just got the CSON file as a string. Can I extract out the magic and the version? And so I can reason about what file format I've actually got here, and then I can map that into calling the correct decoder and things like that. You're calling the correct decoder basically. So yeah, we need a way. So this is basically the code here. So we need a CSON reader. Yeah, so the function was sort of like this. So we'll go into encoder.h for a moment. So stuff to do with CSON around here anywhere. Text reader. Right, type info. Some of the common bits and bobs. Default values for CSON reader. Text reader is not CSON, it's slightly different. It's for quickly parsing text if you don't want to tokenize it. I might change this to CSON reader. Let's plop this in here for now. So effectively this will be a way to decode header or decode the header and what you're getting back. So you don't pass in anything but the CSON string, and the file path is nice for the error messages basically. CSON string, and then you want a magic out and a version out. I could make a structure and just call it, I've already got one here for the bin header, but yeah, I just want a trimmed down version. This would be the encoder CSON header. And that way we only need one pointer. So you could just return that as a struct. So that will be, so you create yourself a CSON reader. Now the CSON read, oh yes, that's an internal thing. Yeah, so that'll work. Right, I'm happy with that. So let's go ahead and find where I can stick this and encode. There's somewhere in here I can stick it. Right, no decode stuff in here. But yeah, CSON decode. We'll stick it here. Right, so what we're looking at doing is we don't need the magic anymore. Yeah, so what is the expected magic in this? We don't really have an expected one. So how might one navigate this? So we could go back to using a pointer. You pass in a null pointer, then it means that, yeah, because there isn't really a nullable value. So we need to, you solve every problem with indirection. That could solve it. Still going, that's good. If latest version. Yeah, so we need to go to the header files and quickly change those. And then inside the code generator, so that's code, yep, where we do the reader side of things for the magic, take the address as we had it before. There we go. Nice. So that means here we can then have our own sort of like header encoder CSON header. I don't know what everyone really will call it. Let's just call it. Hey there, Bob Ross. How's it going? Pleasure to have you. Yes, we're going out to header magic. Oh wait, null, because that's the expected, then the out is header magic, then header file version. Now the thing is about the, oh, yeah, it's interesting. The CSON decode, it usually returns a pointer to the settings, doesn't it? And they're custom allocated. So it has a way to tell you if there was an error. There's no way to tell you there's an error if you just return the header this way. So this should probably return a boolean instead. And then this will go What have you been working on? Or what have I been working on? So I'm working on. So we've made this sort of system where we can run shaders. Okay, what's the way of saying it? We've made a shader which can be used to make these different materials, and it essentially works by running some like a stack-based VM per pixel, which essentially pushes on noise values and then operates on those noise values. And then there is another instruction which colors it, and does sort of a PBR, albedo, emissiveness, roughness, meltness, and it can generate these sphere textures and produce some different looking materials, which is quite cool. So what we're building is this sort of the big high level task is a material editor. We've just built this sort of first proto material, as we call it, which is the shader, which takes in a bunch of inputs and generates a material from it. We're currently working on the descriptions of the materials themselves now. So we've just built the proto material definition. So how do you declare a new like shader and the inputs that go into the shader, the data definitions and all of this? So that's done. We've put in this all of the input data that makes this material. We've put it into a text file. Right now I'm just trying to solve the problem of we've got a bunch of these text files that reference different procedural materials, and how do we sort of link the two together? So I'm putting the magic number in our header basically, and that magic number we can use to link back to the correct procedural material. So when you open up a material asset in the editor, you can, oh, someone say hi. Thank you, Luigi. Oh, it's Luigi. Yeah, when you take that text file which just describes all the inputs to that procedural material, how does it link to an actual procedural material when it could be any one of them? And that's what we're just sorting out for that. After that, we're going to be defining the baked material, which is like all the pixel data and stuff like that. And then when we have all those things, we're going to actually try and build the materials from all of this data without the editor side of things done. And then after that works, we start on the editor. So yeah, just getting all the back end bits in, back end bells and whistles, as you do. Gonna be good. Yeah, so we'll want something like that, would be good. Right. So now we've got this way, right? If we have a CSON file, which is just a C like JSON, we just give it the CSON and the file path, and then it can give us a nice error message if it fails, but it reads the top part of the CSON file. So that was in edmat. Yeah, this one. So the volcanic ground material. So it just reads these two lines, probably that way around. Maybe. Yeah. Yeah, that way around. Reads those two lines, and then we can decide what we want to do with it. How to, which procedure material do we decode, basically. Awesome. Have you ever heard Caravan Whiplash? I have heard of them. It's a band, isn't it? I've never listened to any of their stuff, though. You know what? I'm not going to Google it there because every time I Google stuff, it's like Hey, you live here. Let me just Google my phone for a minute. Because if I Google like caravans, it's like, there's caravans in your area. Searching for your postcode. Right, I'll give them a listen. Got them on my phone. Thank you. Is it one of your favorite bands? Today I've been constantly debugging and implementing new features to a website, and I learned that using the Cloudinary API with Rust is a real pain. Right, I didn't realize it was Cloudinary. Oh, man, I'm so damn tired. Okay, so let's go back to the plan. So, today what we've done, we have declared this procedural material. We've got an implementation as well. So we declared the data definition. We've made a CSON file, editor proto map file. We've made one of those, which describes that sort of general virtual machine version, material, procedural material, which is pretty cool. We've also written out a shader input type for that general procedural material, proto material. I should just rename it to procedural material. What am I doing? And then we've also implemented the CSON file, and for the volcanic ground one. Yep, it's pretty good. So what's left is we need to make another one for the baked material asset. And then we need to make a start on... I didn't regenerate this, did I? The tools. Yeah, crap. $31. Yeah, we could put null in there and that might just work. That'd be pretty legit. Right. Yes, so we just need to clear the baked material now. So it's just basically a bunch of pixel data packed into a single asset. I was thinking of compressing stuff. Compressing the pixel data. We've got block compressed already. But I was thinking about compressing this raw pixel data. But that's just going to be effort. We can always change it later, I guess. Since they're baked assets, they don't really have to care about their versions or upgrades. They can just change the version, and you just have to have the latest version, and that's it. So that baked asset shouldn't take too long to do, and then we can start work on... Yeah, so we've done a lot of this today, basically. Oh, we need the material palette, damn it. Yeah. I think about it. I don't know if it is a club, but I watched a movie called Whiplash, where they play Caravan. Right, I see. Yeah, well, I'm kind of closing up the stream soon, so maybe some other time. Kind of getting tired. Yeah, I'm not sure what to do about this material palette. I'll think about it off stream. But yeah, then I guess we'll be working on these builder functions next. After we've made... Yeah, so that's the thing is, do we put it in graphics or in the editor? I think we could just move it all into graphics. Yeah, it would probably be better. The editor's more of just a visual front end, maybe. I don't know. It's hard. It's why I just put it all in a single file. Does the job. Hey Katsumoy, how's it going? Is it standard practice for engines to compress pictures? I thought you just use PNG files. So yeah, you can use PNG files, but the problem with PNG files is you... I've heard they're quite slow to compress. I've not decompress. I've not tested it. The other problem is you've got to include that as a dependency. So right now I'm not compressing it because then I don't have to go and, you know, write the code to compress it and decompress it basically. PNG also only supports RGBA data, right? So, you know, when you've got different formats like these ones, then it might not be a good fit, the PNG file format, right? So the other way you could do it is you could just zip compress the pixels, and that does a reasonably good job. But yeah. So you can use just a compressor basically, like a standard compressor like Z standard or zip. I've done some tests on it before. See if I can find the results. Hang on a minute. Secret mode. I'm looking around for my secret. Right. Oh yeah. Okay. Is this all okay? Yeah, I can show this stuff, I think. Yeah, this is fine. Boom. So yeah, I made this file. I took a screenshot in the game and I converted it to a BMP file. So it's basically raw. It's 20 meg. And I LZ4 compressed it. It went down to 8 meg, and I Z standard it, and it went down to 7.4 megabytes. So yeah, you could just use a general compressor. That's another option. So yeah, I might general compress it, we'll never know. That's always an option for these uncompressed ones. But yeah, typically engines will basically just block compress stuff, and they'll probably use BC6 and BC7 because they're high quality. Right. So yeah, thank you for tuning in today, guys. There is the code if you support the channel. You get access to the code. I will be committing this to the repo tonight, I think. Yeah, and then next stream we'll work on the writing the actual material, baked material, and the start work on the material builder. We'll probably shuffle some files around because I might have thought about where these things should live. But it'll only be a small change, I think. Right. Man, I'm so damn tired. I woke up at 5:30 this morning because what happened? Yeah, my boy is ill, so I woke up super early. Right now my eyes are so damn heavy. But yeah, have a good Wednesday, guys. I won't be here Thursday. It's my birthday, so it'll be Sunday. Oh, anyways, I'll post that in the Discord. Have a good weekend, and I'll see you all on the weekend. Right, bye bye. Oh, thank you. Appreciate it.